Okay, so just as a quick review from the terminology, so remember this symbol here from a previous section, what does that symbol imply? Element of. Okay, so element of. And we use that when we're talking about specific members of a set. So for example, is this a true statement, true or false? Is 3, I'm not even going to mention the phrase, but what if I had this? Is that a true or false statement? That's a true statement. So 3 is an element of that set because you can see it. Now remember we talked about cardinality, so we're going to talk about cardinality again when we talk about Venn diagrams. What's the cardinality of that other set on the other side? Remember what it is? 4. The number of elements. So your first quiz in here is going to be next week. At the end of the period, it's going to cover section 2.1. Okay, section 2.1. Okay, so cardinality. So cardinality is 4. So this is a true statement because 3 is an element of the set. You can actually see it. Okay, that's a true statement. And the other thing was this. So if you saw this, what did that represent? Not an element of. Okay, so not an element of. So in section 2.1, we're just talking about, I know a lot of things we covered in 2.1. There's like 8, 9 objectives altogether. But basically, you just talk about basic concepts about sets. Now we're going to talk about subsets. Subsets. All right, subsets. So again, section 2.2, subsets. All right, so let's start with the first objective. The first objective, what you want to do in here is recognize subsets. And the symbol for subset, see what it looks like? So it's kind of like this, I don't know, let's call it a C with a line over it or a little segment over it. I mean, under it, excuse me, under it. So that means subset. In a little while, we're going to talk about proper subsets. But this for right now is just subset. So, in the blank, you would say a set A is a subset of B, and that's what it looks like. So you would say A, and then that symbol for subset. So we're just going to call it a subset symbol. So the subset symbol looks like this. Don't confuse that with element, though. So here we're talking about a set being a subset. In section 2.1, we're talking about a member being an element. So those are different ideas. They kind of look alike, but one we're talking about member being an element of. Here we're talking about a subset being a set being a subset of. So one was member, one was subset. Okay, so a subset A is a subset of set B, and is symbolized by A is a subset of B, that symbol. If all the elements of set A are also elements of set B. Okay? So, a set A is a subset of B if all the elements that are in set A are also where?
Set B.
In set B. Right? So, for example, suppose that set A is this 1, 2, 3, 5, 8, 10. And here's the question. Now we know from last class period that 2 is an element of this, right? You all agree? All right, so 2 is an element of. So remember, I'll just put A. So 2 is an element of A. Y'all agree with that? Okay, but let's talk about subsets though. All right, now remember we're asking, is this set a subset of the other set. So if I'm talking about sets, I've got to write it as a set. So here's the difference in terms of notation. So here's the question, or here's the idea. I'm going to say B is this set. 2, 3, 5. Okay? So B are the elements that contain that set. Is B a subset of A? Yes or no? Yes.
Yes,
Why?
because all the elements of B are in A.
Okay, good. Because all the elements of B are in A. Is 2 in A? Is element 3 in A? Is element 5 in A? Yeah. So A is the bigger set, and then part B, or set B, is a subset of that, because every element that's in B is also in A. Now here's how we write this though. We say this instead. We don't use a symbol element, because this is not written as an element, a member. This is written as a what? Set. So we say subsets instead. So we say this. So we say, so therefore, B is a subset of what? A. Okay? So B is a subset of A. Yes.
So you sent a worksheet that included this information. Were we not supposed to do that?
No, I'm going to give you that worksheet today. So I always post the worksheets.
Oh. You already posted it though, right?
Yes.
Oh.
Yeah, did you print it?
Yes, and I did it. And
Oh, no.
I thought we had to do that.
No,
I'm
no.
still trying to figure out the workload for this class. So.
Yeah, it's going to be quite a bit, because you're only meeting once a week. But you only do what I tell you is assigned. So usually when you're here, I tell you what's assigned. So the only thing that was assigned for today was those 2 worksheets from 2.1. Okay? So I post the worksheets just in case somebody's absent today. So I wanted to already have posted it.
Okay, thank you.
Okay, yeah. All right, so B is a subset of A. Okay? So let's go back to that handout that I gave you. So this symbol right here, this is where we're at. The symbol right here means that set A is a subset of set B. So set A is a subset of set B. The next line. This symbol right here looks like this. Tell me about that symbol. What do you think that means based on what we did last class period?
It's not a subset.
Is not a subset. Good. Do you remember the not an element? That symbol looks very similar, except this one means not a subset. So that symbol is used to indicate is not a subset. All right, and so right here again, so where I have A and B, so thus this right here means that set A is not a subset of set B. So set A is not a subset of set B. All right, now here's the question. So I'm going to go back to our example we were working on, and I'll come back to the rest of this. So here's the question. Let's suppose this. C is 1, 2, 3, 9. Okay? C is 1. C has the numbers 1, 2, 3, and 9. Here's the question. True or false? C is a subset of A. True or false? C is a subset of A.
False.
Why is it false?
Because it has a different element.
Okay, because in order to be true, in order for a set to be a subset of another one, every element of that set has to also be elements of the other set. So that's a false statement, because in order for it to be not a subset, you gotta find one element that's not in the other. So is there an element in C that's not in A? Yeah, what element? None. Okay, so that's a false statement. False statement. So that's false since 9 is an element of C, but 9 is not an element of what? A. Okay? So that's a false statement because 9 is an element of C, so we found an element that doesn't work. 9. 9's in C, but 9's not an element of set A. Okay? So that's going to take us to the next part on that handout I gave you. So to show that set A is not a subset of set B, we must find at least one element of A that is not an element of B. So we must show that there's one element, at least one element of A that is not an element of B. Okay, you understand what that means based on what we just did? So, again, just kind of like a quick review on that part. True or false? So that's number 1. Number 2, true or false? Is B a subset of C? True or false? B is a subset of C. True or false? That's false because B has what element that's not in C? 5. Good. All right, let me make a D and then we'll be done with that little part. D, suppose D was this. 1, 2, 3, 9, 11. Okay, true or false? So that's false, right? Okay, number 3, true or false? Is C a subset of D? Why is it false? That's a true statement, right? Because in order to be true, remember I'm asking, is C a subset of D? So every element of C has to be where? In D. Is every element in C also an element of D? Yes, that's a true statement. So that's true. Yes, it was the other way around, it would be false. So the question is D a subset of C? True or false? That's false, because what is in D that's not in C? 11. So it'll be false. Okay, so that was objective 1. Okay. Oh, before we go on, let me ask you this. I forgot to mention this. So remember, in order for a set to be a subset of another one, every element of that set must also be in that other set, correct? So here's my question to you then. True or false? Number 5, true or false? Is B a subset of B? Yeah. Because every element in B is also an element of what? B. So every set is a subset of itself. Every set is a subset of itself. So that's true. So every set is a subset of itself. Okay? All right. So that was that last thing you saw. You see where it says right here, every set is a subset of itself? So now you visually saw why that's true. Okay? Now, let's talk about proper subsets. Proper subsets. So we talked about subsets. Now, you all know what the symbol is, right? Symbol is for subset. Proper subset. Here's the symbol for proper subset. Proper subsets is this. Proper subset. All right, here's the symbol. It's just that thing that looks like a C. That's it. You don't have that segment underneath. Is that clear? So that means proper subset. This means what? Subset. So that just means subset. Okay, so one symbol means proper subset. The other symbol means subset. So notice, make sure you know the distinction between the two. One's proper, one's just subset. All right, so here's the distinction though. It's not that difficult to remember. Here's the distinction. Okay, so we're going to start out with an example. All right, so let's suppose that set A is this. And B is this. Okay, and C is this. Just write these down. All right. Okay, now, so one of the things you can be asked is this, and then we'll kind of discuss whether this is a true or false statement. So true or false? Is A, number one, is A proper subset of itself? That's the question. Number two, is A subset of itself? That's the other question. There's a difference between those two. Right away, you can tell me which one's true right away. Which one's true? Based on what we talked about. Number two. Number two is true. Because we know that every element is a subset of itself, right? So number two is true. Let's talk about number one then. Number one says that A is a proper subset of A. That's what number one says. A is a proper subset of A. So let's kind of talk about the word proper. All right, so go to these notes. Set A is a proper subset of B and is denoted like this. A, and that symbol for proper subset, B. If all the elements of set A are elements of set B, okay? And here's the thing though. Set A cannot equal set B. Set A cannot equal set B. So in order for set A to be a proper subset of B, all the elements in A must also be where? In B, and the two sets cannot be what? Equal. Okay? Two sets cannot be equal. So in other words, set B must contain at least one element that is not in set A. So they cannot be equal. So let's go back to that example, number one. Is number one true or false? False. Number one is false. We know that set A is a subset of itself, but it's not a proper subset of itself. Because in order to be a proper subset of itself, they cannot be equal. And what do you know about set A and set A? They're equal. Okay, so that's false. Okay, number three. Okay, now we know what proper subset means. We know what subset means. Yeah.
So it just means it's not, I'm confused.
Proper subset just means that A set A is a proper subset of set B if all of A is in B and they're not the same set. Okay? So look at these examples. Let's look at some examples that may help you. We're going to use those three right here. So here's the first one, number 3. Is C a subset of A, yes or no? Yes. So that's true, right? You agree? Okay. 4. Is C a proper subset of A? Yes. Yes. C is a proper subset of A. So if C is a subset of A, it's also a proper subset of A. You understand? Okay. So you see it can be both, right? It can be a subset, it can also be a what? A proper subset. Number 5, true or false? B is a subset of A. True or false? That's false. Because there's one element of B that's not where? In A. So that's false. Let's do a D. Write a D down. Let's suppose we had 7 and 6. For D. All right. 6. True or false? Is B a proper subset of A? Don't make it difficult. What is it? That's well. Why? Who said true? Why'd you say true? Say it again. Sorry. No, be careful. In order to be a subset, they have to have the elements in one set has to be in another. In order to be a subset, right?
So if it's a proper subset.
Okay, the difference between, subset, you all know that subset means that every element in that set has to be in the other, correct? And if you find at least one that doesn't work, then it can't be a subset. Proper subset just means that the two sets cannot be what? Equal. That's all that means. So number 6, is set B a proper subset of set A? No, because there's an element in B that's not where? In A. What is it? 1. So the point of number 6 compared to number 5 is if it's not a subset, then it definitely will be a what? Proper subset. Okay? All right, so that's false. Number 7. Is D a subset of C? True or false? Anybody else? I only heard one person and one other nodded. Give me one more.
Yes.
Okay, thank you. That is true. So every element in D is also an element of what? C. But then the question becomes, is D a proper subset of C? True. Because those two sets are not equal, right? Those two sets are not equal. So that's true. Now, make this an E. Make E this. Make E be the set that contains 6 and 7. And actually, let me do this for you. 6, 6, 7. Just to see if you remember some things. Okay, as a review, what is the cardinality of set E? What is a cardinality of set E? Huh?
4.
Why'd you say 4? Who said 4? Why'd you say 4? Just someone you said 4.
Oh, 3. So we took,
Well, okay, why are you saying 3 now?
because the elements are
What are they?
3.
Okay, you gotta tell me what the elements are. You said the elements are, and then all of a sudden you said 3. What do you mean? What are the elements?
Oh, okay.
Okay, now you say, oh, okay, so let's go back to the question. What is the cardinality of set E? Answer me, come on. What is a cardinality of set E? What is the definition of cardinality?
I mean the numbers, number of elements.
The number of elements in the set,
in the
okay?
set, yes.
So, let's go back then.
Yeah.
What is the cardinality of set E?
Well, behind it, the 6.
No, I don't, I have a pen, so I can't erase.
Mhm.
So, put that as a comma.
Okay, so the 67 as an E, or what the whole, which is 67, the continuing numbers are all E.
E has the elements 6, 7, 6, 6, 7,
Oh, okay.
okay?
Okay, I'm with you now.
So what's the cardinality of set E then? Okay.
The 2.
Okay, so 2. So I'm hoping that no one said 5, right? Because if the elements appear more than once, you only list them what? Once when doing cardinality. Okay, so the cardinality is 2. All right, now here's the question. Number 9. Is D a subset of E? Is D a subset of E? Come on, guys. Yes, why? Yeah, because remember a while ago we said that every set is a subset of itself, right? So the elements in D are 6 and 7, and the elements in E are also what? 6 and 7. Okay? Now, number 10. Is D, now how do you read this? D is a what? Proper subset. So is D a proper subset of E? Oh, no. You gotta count, if the elements appear more than once, you only count it once. It's not a proper subset. Because the elements of D are exactly the same as the elements of what? E. So D is a proper D is a subset, but it's not a what? Proper subset. Okay? All right. So it can be a little confusing if you don't quite understand the terminology. So that's why I did all these examples. So that one was true right here. Okay. All right, let's go back to the notes. Okay, so every set is a subset of itself. We talked about that. We understand that. I'm right here. Every set is a subset of itself. But let's see. But no set is a proper subset of itself. Okay, so no set is a proper subset of itself because they have the same elements. Okay? So that goes back to what we just did. So remember a while ago, number 9 and 10? So D is a subset of E, but D is not a what? A proper subset of E. Okay? Now, just out of curiosity, I'm going to direct number 11. So D, this. Is that true or false? That's true. Remember, that reads as D is not a proper subset of E. That's a true statement now. Okay, so let's go back to the notes. So, let's see, there was one that was missing. So sets A and B are not equal. So right here. All right, so every set is a subset of itself, but no set is a proper subset of itself because the two sets are equal. And they cannot be equal if one's a proper subset of the other. So in other words, for all sets A, this is true statement. Y'all agree? How do you read this right here? A is a subset of A, but how do you read this? A is not a proper subset of A. Okay. All right. Now, let's look at this. We're going to use the same sets we did a while ago, set A, B, C, D, and E, okay? Set A, B, C, D, and E. Now here's number 12. Number 12. Let me put that up here. Okay. Number 12. What does that symbol stand for? Do you remember? The empty set. The empty set. The empty set. Okay, so here's the question. Is the empty set a subset of, let's say, A?
No.
Yeah, so remember the idea. So in order for a set to not be, listen carefully to the words, in order for a set to not be a subset of another, you got to find at least one element of the set that doesn't work. Okay? In order, I'm going to draw it this way. In order for a set to not be a subset of another, you have to find an element that's in here that's not in here. Okay? Yeah.
So is it because there's nothing there?
Very good. Yes. Excellent. So the empty set is a subset of every set. Because, based on what I just did with those braces, y'all agree that the empty set can also be denoted as this from the last class period? Well, find one element in here that's not in here. You can't, because why? There's nothing there. There's no element in here. So you can't give me an element that's not in here because this has none of them. It has nothing. So therefore, the empty set is a subset of what? Every set. Very good. Yes, it will also be a proper subset. Excellent. So number 13, so that's true. 13, the empty set is also a proper subset of A. Okay? All right. So, some of you were on the right train of thought with this. You knew that when I'm pointing to that, hey, since there's no elements in there, then I can't show one that's not in the other one. So therefore, it has to be a subset. So I doing a counter example. All right, so let's go back to the notes. So we're having a discussion about the empty set right here, the empty set. So from our discussion, the empty set is a subset of every set. The empty set is a subset of every set. Okay, turn the back. For any set B, the empty set is a subset of B. Y'all agree? Now, I'm sorry, I forgot your name. Well, Lenny and Doug? Dallas, okay. Dallas, remember he said, oh, so does that mean that the empty set is also a proper subset? What do y'all think? Yes. Yep. So for any set B other than the empty set is also a proper subset of B. So the empty set is a proper subset of B. Now notice that phrase. Remember I said it said other than the empty set? Here's what that means. So I'm going to ask you this question then. Here's what that means. That means that the empty set, is that a true or false statement? That's false because the empty sets have no elements, so they're the same, right?
Can't they say they cannot equal each other because they don't have anything to equal?
That's true. Yes. But there. Remember when comparing if two sets are proper subsets, if a set is proper subset of the other, it can't be equal. It can't have the same elements. But you can't do anything with that because there's no elements in the empty set to show if they're the same as the elements of the other set. So it's a little bit difficult to understand that part. Because that's why it says other than the empty set. Because you don't know what elements are in that empty set. There aren't any. Okay, so you can't say that it's a proper subset. How can you say the elements in here are also in here when there aren't any? Okay? All right. But the main take from this is this. You all see now that the empty set is a subset of every set? Okay, that's the important thing. Do you also see that the empty set is also a proper subset? Okay. All right. Now, number 3. So we're almost done with that section. I'll give you the worksheet on that, and then we'll talk about Venn diagrams. Okay, here's the way we want to talk about number 3, objective 3. So I'm going to write kind of like a column and rows. So I'm going to call this column the set. I'm going to call this column the subset. And then we'll call this the number of subsets. Number of subsets. All right, so on the first column, you'll have the word set. On the other column, you'll have the word subset. And then we're going to talk about the number of subsets. Okay? All right. So the first one we're going to talk about is this one. So we have this set. Now, what I just drew was which set? The empty set. Okay? Based on our discussion, can you tell me the subsets of the empty set? The empty set. The empty set is a subset of itself. It's just not a what? Proper subset. Okay? So every set, in our discussion, every set is a subset of itself. So the empty set has to be a subset of itself. Okay? So I'm going to write that down. So how many subsets are there for the empty set? 1. Okay? The next one. Let's say we had this one. So I just wrote a set that has how many elements? 1. So based on that, tell me what the subsets are. And the empty set.
Every set except the
Okay.
empty set will have 2 subsets no matter what.
What?
Every set except the empty set will have 2 subsets.
No. So what you're thinking about if it's just one element. If it's just one element, it will have two subsets. So you have the empty set and you have itself. So that's two, right? What if you had this? So based on what he said, he's thinking that there's going to be two just for that one also. True or false? False. Okay? So now we get to the point where you have to kind of draw some things to help you determine what the subsets are. First of all, you know the first subset is going to be what? The empty set. All right, let's draw the empty set. So far we have one. Then, based on those two elements, give me some other subsets. A set with just the element A, right? A set with just the element what? B. And a set with both of them. Because remember, a set is a subset of itself. Okay. So do y'all agree that'll be this? Right? So how many subsets are there? 4. Okay. A, B, C. All right, so now we're not going to go further than that because it'll take forever. We could easily miss one. So let's do this one. So you know that I'm definitely going to list what? The empty set. Then let's do in a efficient process. So I know that I can also do subsets in which there are how many elements in it? Just one. So I can automatically have the set A, the set B, and what else? The set C, right? So what I did at this point was I wrote subsets in which there was just one element. Then we'll write subsets in which there are what? Two elements. Okay? So give me one.
AB,
AB, and what else?
AC,
AC. And what else?
BC.
BC. Y'all forgot about BC. I think that's about it, right? AB, AC, and BC. Okay? Then what else am I forgetting though?
ABC.
The what?
ABC.
ABC. I'm forgetting the set itself. So ABC. So how many are there? 8. Okay. Now, let's look at the pattern here. So see where I have the number of subsets all together? So this one's 1, this one's 2, this one's 4, and this one's 8, right? Okay. So what I want you to notice is that to go from here to here, I multiplied this by what? 2. To go from here to here, I multiplied this by 2, and then go from here to here, I multiply this by 2. So if I had, just out of curiosity, if I had A, B, C, D, then there will be how many subsets? 16. There'll be 16 subsets. So let's talk about those numbers 1, 2, 4, and so on. And notice I did times 2 each time, right? So let's look at the number 4. Yes.
I know what it is.
Well, hold on. Let's go through the discussion. You probably do. Let me just go through the discussion first, okay? So that way the others can see that. Okay, so let's look at 4. Do y'all agree that 4 is 2 times 2? Okay, let's look at 8. Do y'all agree that 8 is 2 times 2 times 2? Okay, let's look at 16. Do you agree that 16 is 2 times, it's 8 times 2, so that's an extra 2, right? And this is just 2, correct? And I'm going to leave this alone for right now, the 1. Well, the one that I have 2 times 2, I know that from a previous course that I can write this as an exponent, 2 to the second power. And then 8 I can write as 2 to the third power, and then 16 I can write as 2 to the fourth power, and then 2 I can just write as 2 to the first power. Okay? And that, I put a 0 here. I meant 2 to the second, right? Okay, 2 to the second. So then I want you to compare the exponent. I want you to compare the exponent and see where that exponent you think came from. So the exponent 3, let's say. Why do you think there's a 3 there? Why do you think there's a 3 right here? Because there's 3 elements. Why do you think there's a 4 here? There's 4 elements. Why do you think there's a 2 here? 2 elements. Why do you think there's a 1 here? 1 element. So let's go here. What should be the exponent here? 0. So you remember in a previous course that any number raised to 0 power is equal to what?
0.
Oh, no. Any number equal to 0
1.
is 1. Y'all remember, you probably learned that in a math course. What was a prerequisite in your course? Did you have to take a prerequisite? Yeah, so you probably learned that in that prerequisite course. So 2 to the 0 power is 1. In fact, if you put that in your calculator, you put 2 to the 0 power, it's going to say 1. Okay? All right, so there's a formula for that, and what was the formula?
2 times the number of units in the set.
No, it's not 2 times,
I mean,
it's 2
2
raised
to the power.
to the, okay. So here's the idea. So if there are n elements, if set A has n elements, okay, then the number of subsets, then the number of subsets of set A is 2 to what power? N. 2 to the n. Okay? So 2 to the n. So let's go back to our notes and let's kind of fill that in. All right, let's go back to our notes. So we had this discussion. So right here was our discussion. Say it again. If set A has n elements, then the number of subsets of set A is 2 to the n. 2 to the n. Okay. So the number of and we're talking about distinct subsets. Okay, number of distinct subsets. So all of these right here were distinct. No set was the same as the other. So that's what we mean by distinct. So the number of distinct subsets of a finite set A is 2 to the n, where n is the number of elements of A. All right. Now, I'm going to ask you this. I'm going to go back to our table. Go back to our table, and I am going to, somewhere around here, there's not enough room, but right here I'm going to say the number of proper subsets. That's supposed to be number of proper subsets right here. You can't see it very well, but that's number of proper subsets, okay? So think about our discussion earlier. Subsets, proper subsets. Let's go to the element with just A in it. How many subsets were there? 2. How many proper subsets are there?
1.
1.
Wait, so the formula would just be 2 to the power of n minus 1.
Because when we do this one, we can't use A. Because remember, A cannot be a proper subset of itself. Over here, we can't use which one? AB. Over here, we can't use which one? ABC. So the number of proper subsets are all decreased by what? 1. So if there were 2 here, there are how many proper subsets? 1. If there were 4 subsets, how many proper subsets? 3. If there were 8 subsets, how many proper subsets? 7, right? And there are 16 here, how many proper subsets? 15. If I go over here, if there was one subset, how many proper subsets? 0. That goes back to our discussion a while ago that we were having difficulty understanding. The empty set cannot be a proper subset of itself. But it can be a what? Subset.
Subset.
Yes.
So all those other ones, they proper subsets like on A, B, C,
Yeah.
regular A's. and
Yeah.
subsets.
All these sets. This right here is a subset of this. It's also a proper subset.
Okay.
Yeah. So remember in our discussions and some of the problems, we saw that set A was a subset of B. It could have also been a proper subset. Yeah. So that's a proper subset, that's a proper subset, that's a proper subset, that's a proper subset, but not this one, because that is exactly this. Okay?
So are you subtracting one?
Yes, you are. So basically the formula for, so if set A has n elements, then the number of proper subsets of set A is what? So if set A has n elements, then the number of proper subsets of set A is what? No, not 1. The one with 16 wasn't 1, was 15. It can't be 1. You're telling me that every set, that there's only one proper subset? Not true either. How can you say 2? I want you to understand what you're saying. You're saying that this element right here, this set has only 2 proper subsets. We saw that it has how many? 15. This has 3 elements in it. This has 7. You're saying that's 2. It can't. They're not all 2s. What's the formula, guys? 2 to the n minus 1. 2 to the n minus 1. Because all you're doing is you're taking the number of subsets and doing what to it? Subtracting 1. All right, so on that blank right here, see the number of distinct proper subsets? So what thing goes in that blank? The number of distinct proper subsets of a finite set A is what? 2 to the n minus 1. 2 to the n minus 1. Okay? All right. Now, here's what I want you to work on. And I'll give you about 10 minutes to get started on this, and then we're going to start looking at Venn diagrams. All right. So listen carefully.